College algebra students, we have this quadratic function y equals 2x squared minus 8x plus 3. Basically what we're saying is, given this quadratic function, tell me everything that you can about its graph. And of course its graph is a parabola, so we need its vertex. So there are a couple of ways we can do this. We could use the vertex formula, or we can try to rewrite this expression in vertex form. So notice that the coefficient of x squared is not equal to 1. So what I will do is I will factor out a 2 from these first two terms. So what I have now is y is equal to 2 times the quantity x squared minus 4x. And of course, I still have the plus 3. Now what I'm going to do is I'm going to complete the square. This is something that we've done with circles. So I have x squared minus 4x. Let's see, what do we do to complete the square? We add half of the coefficient of x squared. Half of negative 4 is negative 2. Negative 2 squared is 4. So I'm going to add 4 here to complete the square. Now be careful, okay? I added 4 here, but remember there's a 2 outside here. So whatever I'm doing here, I'm doing twice that. So when I add 4, I'm really adding 8. So to maintain the balance, I have to undo that by subtracting 8. And of course, I still have the plus 3 here. Now, look at what I have now. I have 2 times, now x squared minus 4x plus 4, that's a perfect square. That was kind of the whole point of what we just did, right? So I have 2 times x minus 2, the quantity squared, and negative 8 plus 3 is minus 5. Okay, so y is equal to 2 times x minus 2, the quantity squared, minus 5. This is what is called vertex form. We started out in standard form. This right here at the beginning was standard form. Standard form, again, is what? Y is equal to ax squared plus bx plus c. Okay, so now that we have this in vertex form, the vertex is the ordered pair, what? 2, 5. Now once you know the vertex, 2, negative 5, we compare this to what? A times x minus h squared plus k, in this case, what? H is 2 and k is negative 5. So the vertex is 2, negative 5. The axis of symmetry is x equals 2. The y-intercept, how do we get the y-intercept? What I recommend is go back to the original equation. To get the y-intercept, just plug in x is equal to 0. If x is equal to 0, y is 3. So we have the order pair 0, 3. Now the x-intercepts. To get the x-intercepts, what you have to do is you have to set y equal to 0. So what you'll do is go back to this equation here. We already did the work involved in completing the square. So you have to solve 2 times x minus 2, the quantity squared, minus 5 equals 0. We're going to get 2 solutions here for x. So we're going to end up using the square root property. Add 5 to both sides, divide both sides by 2. So we have x minus 2, the quantity squared, is equal to 5 halves. So what we get is x is equal to 2 plus or minus, using the square root property, square root of 5/2. So as you're working this out, you're going to get two possible values for x. X is about 3.58, or x is about 0.419. So they're both positive. Okay. Now what you should notice is that they're the same distance from 2. So we have the x of symmetry, x is equal to 2. The x-intercepts are equally spaced around 2. One of them is 2 plus whatever the square root of 5/2 is. Remember, 5/2 is 2.5. It's about 1.58. So each of these x-intercepts are 1.58 away from 2, about. Okay, so those are the x-intercepts. Now what about the range? Remember, this is a parabola opening upward. That's important. So the y values go on forever. So what is the minimum here? The minimum value happens at the vertex. So the range would be -5 to infinity.